Hi, and thanks for joining today. My name is Grace Kitzmiller, and I'm the Principal Product Manager for the AWS Disaster Response Program. I'm excited to be here today to talk to you about how drones and snowballs were used after Hurricane Dorian hit in the Bahamas to get updated aerial imagery into the hands of decision makers faster than they had been able to before. After that, we will talk a little bit about how the AWS Disaster Response Program team activated and deployed in order to support that response activity in the Bahamas. And last, we'll wrap up with how both of these experiences are translating into preparation activities for other NGOs and humanitarian organizations that have similar needs. Okay, next, this is just a quick recap of the agenda. So let's go ahead and dive right into the Hurricane Dorian response activity. Now, for those of you who aren't familiar with Hurricane Dorian, this was a Category 5 hurricane that made landfall in the Bahamas in September of 2019 and was one of the worst natural disasters to ever impact the island. In addition, Hurricane Dorian was one of the two most powerful tropical storms to ever make landfall from the Atlantic. When Help.NGO was activated in order to support response activities, the mission of their Global Disaster Immediate Response Team is to actually fill that gap between the time when a disaster occurs and the time when a traditional response activity is spun up and fully operational. Now, Help.NGO knew that as part of that response activity, one of the things they wanted to be able to do was to get the aerial imagery processed very quickly and into the hands of the decision makers much faster. But they knew they might need some different solutioning and different resources than they had used to date. So they developed their list of requirements, and these included a solution that had a large repository of storage volume available in order to accept all of the images that were collected during those daily flights. The solution had to be able to run the imagery processing pipeline from raw all the way through to processed imagery and run it quickly so they could produce that and share that imagery out faster. The solution also needed to be able to run in a low or no connectivity environment and on unconditioned power if that was required. Help.NGO brought these requirements to the AWS Disaster Response Program team, and based on an assessment of those needs, it was determined that a Snowball Edge compute optimized device was a good fit for those particular requirements. The AWS Disaster Response team then deployed with Help.NGO in order to help implement and configure this imagery processing pipeline and support the response activities on the ground. So what is an AWS Snowball Edge device? Well, this slide shows a picture of a Snowball Edge, and it's a little bit like having a bit of the cloud, AWS cloud, in a portable, ruggedized storage device that you can actually take with you, although it provides both compute and storage and can run in both connected and disconnected environments. A Snowball Edge weighs a little bit less than 50 pounds or 22 kilograms, and it's slightly larger than the size luggage bag that you can typically put in an overhead bin on an airplane. This is the slightly next size up, so that you would be required to check it. It's ruggedized for field use, tamper resistant, tamper evident. Data stored on the Snowball are encrypted using 256-bit AES encryption. And the Snowball Edge can operate on unconditioned power and in austere and dusty environments. Now last, the Snowball Edge compute optimized device, there are a couple different versions of devices in the Snow family. We'll talk about those in a few minutes. But the compute optimized device has up to 42 terabytes of storage available and 200 gig of processing power available to run different kinds of applications. And when we talk about the Snowball Edge being a little like having a little bit of the AWS cloud in a box that you can take with you, what does that really mean? We talk about it this way because the Snowball runs many of the same AWS services that are available for customers to run in the cloud today, including Amazon Elastic Compute, Amazon Simple Storage Service, Amazon Elastic Block Storage, AWS Lambda. And with this kind of configuration, and particularly in support of Help.NGO, Amazon S3 was available in order to potentially pre-provision, pre-disaster geospatial imagery or street map data onto the Snowball. EC2 could be used to set up what's called an Amazon machine image that included all of the software tools and resources that are needed to run that drone imagery processing pipeline from end to end. Lambda could be used to trigger image processing activities as soon as files were dropped into S3 from those new and completed daily drone assignments. And if needed, the Snowball could be run using a generator rather than relying on a consistent power supply. So let's take a quick look at the Help.NGO solution architecture. So every day when the drones completed their flight activities, the SD cards were brought back and transferred over to a laptop. Now the laptop was connected into the Snowball using just a simple router that was broadcasting a Wi-Fi signal from a connection on the Snowball device, but there was actually no internet into the Snowball device or the laptop itself. So the imagery on the SD cards would be transferred onto the Snowball, onto the S3 bucket. Now, in order to process that imagery quickly, we were able to stand up 9 virtual machines running at the same time so that we could quickly process the 2D imagery output from the drone overflights with the 3D imagery to follow up later. Now, this entire pipeline meant that Help.NGO was able to share out those imagery resources, those updated imagery resources, with the decision makers much faster to use in their planning around resource allocation, situational awareness, and just general decision making on next steps in their path forward. Next, I'll play a short video on that Help.NGO put together to reflect on their activities and the use of the Snowball for the Hurricane Dorian response.
We're in the Bahamas. Hurricane Dorian just hit.
There's a lot of work ahead, and drones are going to play an essential role in the relief effort.
Stuff you can do with the drones, the applications are endless. When we deploy into a disaster area, we can get accurate information immediately into the hands of the operations center.
We need to be able to assess the needs of the island as fast as we can, because saving time means saving lives.
The artificial intelligence within our servers allows us to help instantly identify anything that we teach the AI.
This is an area of debris. We picked up a collapsed boat here. We picked out a collapsed house.
This is the hub of the information that's coming out of a disaster zone. When you start thinking about how much information is in just this map, it's life-saving.
So looking back, Brendan Harvey, the executive director of Help.NGO, reflected on how the ability to streamline that drone imagery processing pipeline with a Snowball Edge really helped them to be able to rapidly provision those mission-critical information to the humanitarian decision makers. So next, what is the AWS Disaster Response Program, and how did we align and activate to support Help.NGO? So the AWS Disaster Response Program is an initiative focused on supporting non-governmental organizations, humanitarian and nonprofit organizations, and government agencies and ministries in applying technology to accelerate or expand their disaster response and resiliency capabilities across both the natural disaster and the crisis life cycles. We work backwards from the needs of these organizations to identify what are their biggest technology needs and gaps, and what do they encounter as they're preparing for, responding to, and recovering from a disaster or crisis that technology could help support. And we do this through 3 mechanisms: through people, information, and technology. On the people side, we engage with AWS experts to assist with technical challenges and provide support for activities such as responding to bushfires in Australia, wildfires in California, COVID-19, hurricanes, typhoons, earthquakes, and more. And we support organizations around the world both remotely and in the field. And when we deploy, our trained technical volunteers assist with technical needs such as networking, restoring connectivity, situational awareness, imagery processing, and more. Our remote volunteers can support with both digital and distance activities, including call center support, online mapping, and providing technical expertise and guidance around infrastructure and scaling. From an information perspective, there's a vast amount of information that organizations active across the disaster lifecycle are using. This could include, geospatial, population, weather, terrain, street map, and other information. We work with organizations to either help them collect information, curate information, or be connected to those information providers. And we're seeing more and more organizations looking at how can they aggregate, analyze, and visualize this information in order to support their mission analytics and their decision-making activities. From a technology perspective, we work across these organizations to explore their technology gaps and use cases and identify AWS technology and services, as well as AWS partner solutions that either currently could meet or may be extended to meet the needs that they're encountering. Some of the more common use cases that we hear about are database storage, compute, analytics, machine learning, IoT, and more. And that was some detail about what we do. So let's briefly review the why, when, and how we do it. So why do we do it? Well, recognizing that preparedness is a key component of resilience, we work with customers to establish a playbook for solution deployment and volunteer activation if appropriate, so that both can be deployed more quickly in times of need. And this is how we were able to engage with Help.NGO so quickly, and it gave us the ability to move much faster. When we do it, well, those response levels are based on the severity of the incident and the need that we hear from our customers. And how we do it. Our field deployment staff and our remote deployment staff are really a roster of volunteers from throughout Amazon that are interested in giving back and supporting organizations in times of need. Now, our deployable volunteers are certified in first aid and CPR and trained in the National Incident Management System training, and many have also been trained in the field with other responding organizations such as ITDRC and NetHope. This next slide shows an image of the disaster life cycle. I'm sure this is familiar to many. It includes preparation, response, recovery, and mitigation. And each one of these phases has some important considerations. I'd actually like to focus on preparation for the rest of this presentation. Earlier this year, in one of the few in-person conferences that I attended, I heard something that's really stayed with me, and that is, hope is not a plan. Now, this quote and variations of it have been attributed to a number of different people. But in thinking about it in the context of a disaster or a crisis and preparedness, I hope the hurricane or typhoon doesn't make landfall here. I hope a tornado doesn't touch down. I hope there's not an earthquake, or I hope COVID-19 cases don't spike in my town. This is a common plan for many, and unfortunately, it doesn't position an individual for the best outcome or the communities that you may be interacting with for the best outcome. Preparation flows into response, recovery, and mitigation. And the better prepared you are, the more flexible you can be in adjusting that plan once you hit the ground after a disaster occurs. And this is key to how the AWS Disaster Response program engages. We work through these topics with organizations today so that we can better prepare to support during a response tomorrow. By preparing and facilitating use and access to the cloud and AWS, by thinking about, what are those mission critical data sets? What are those applications that you need to be able to run and have access to? Working together on these topics before a disaster occurs can help us to really better support resiliency through faster response, risk mitigation, and faster recovery. Now, let's turn to a preparation activity and how the Help.NGO deployment and the disaster response program engagement process come together to support a preparation activity. So earlier this year, we participated in a preparedness exercise with a non-governmental organization that's active in rural Africa. The NGO wanted the ability to interact with and drive meaningful results in real time from local data collection activities, and more specifically, a way to process and use drone and UAV imagery that's collected in the field by combining it with some pre-disaster information in order to prioritize areas for more attention. But they faced a few challenges. The area was hard to reach. It has a significant flood history. There's a limited power supply. There's low or no connectivity. And it required a several-hour drive through a combination of paved and unpaved roads. In addition, in order to serve this community, especially given the connectivity and other constraints, they wanted to be able to process that imagery in the field and develop insights from it so that they could more quickly identify potential disaster-related or ongoing humanitarian needs and get that information into the hands of both the local decision makers as well as when they eventually returned back into an office location, they could sync that information back up into the cloud for additional analysis. And their real goal was to make this information available in days or less than a day, rather than the weeks that it was taking currently to process this information. So to support this preparation activity and define the parameters of the exercise, we walked through a number of questions to identify the areas where the cloud and technology could help and assist. So we started the process by asking, what are the most common types of disasters or humanitarian needs that you're responding to? What are the data and apps that you'd like to be able to access, say, immediately after a disaster? How about a day, a week, or a month later? And what is your plan if you can't access those resources, either due to a physical barrier, such as building damage or flooding, because of limited access to power, limited connectivity, or just an inability to travel? And next, really, what apps and solutions do you currently use to improve situational awareness or for field activities? And what apps maybe would you like to be able to use that you haven't found a way to be able to access today? Also, how long does it take to collect and process the information that's available in the field? And then last, is there an opportunity to analyze existing data to develop insights into areas most likely to be impacted and use the results of those analysis for planning and preparation activities? Now, walking through these questions can seem very overwhelming to organizations as they're getting started, but working through these questions helps to surface the areas of need where AWS and the cloud can help. So from databases to storage, compute, website and application development, backup and recovery, call centers, chatbots, analytics, machine learning. There are many ways that the cloud can help across this disaster and humanitarian lifecycle. So after walking through these questions and based on the information that was provided, we collaborated to develop a set of solution requirements for the exercise. And those requirements were to have a large storage volume to allow for collection of volumes of drone imagery and other information that might be available, the ability to run applications for imagery processing and viewing, the ability to operate with limited power and limited connectivity. And the solution had to be portable, ruggedized, and dust resistant. And then last, it had to be able to provide access to multiple users with or without connectivity. So, this slide will look familiar, but based on an assessment of those requirements and the constraints of the environment, really a ruggedized solution that provides a large volume of storage and large-scale processing power was needed. And these requirements align well with the AWS Snowball Edge Compute Optimized device. And we walked through this slide just a few minutes ago, but from a preparation perspective, when you're thinking about, what are those most critical data sets that you would want to bring with you into the field? Well, with this device, you can bring up to 42 terabytes worth, or you could collect more information. And when you're thinking about, what are those most critical data and applications to be able to run in the field as a crisis evolves or during that recovery? Well, with a Snowball, you can pre-provision applications and have access to up to 200 gig of processing power to handle those high-intensity workloads and run in both a disconnected or a connected environment. And you also have the flexibility to install other solutions that might become necessary as you're operating in the field. And because a Snowball is portable, when the field work is done, you can actually carry it back with you to an office or an area where you might have more connectivity and sync that data back up into the cloud and make it available to other stakeholders that might need to know or be able to have access to some of that same information to help with a response or other activity. So these photos show a little bit more detail about this particular exercise. So this First photo up here on the top left shows the snowballs being unloaded onto a baggage cart after coming off the airplane. This image here on the bottom left shows the drone or UAV flight takeoff and landing area. In the middle, we have our volunteer who is running his laptop connected to this AWS Snowball Edge compute optimized device. And he's connected into the device just through a router that's set up as a wireless access point. And this last slide shows the entirety of the command center for the operation. There is a generator here that the snowballs are plugged into, and of course a canopy for some protection from the sun. So, how do you provision and operate a snowball? We've talked a lot about what a snowball is, how we've deployed, and how these solutions were useful to some of these non-governmental organizations operating in the field. So let's go ahead and dive into a brief demonstration of how to log into the AWS console and provision and run an AWS Snowball. Okay, so the first thing you want to do is actually access the Amazon console. So if you go to aws.amazon.com/console and click to log in. Next, when you see the AWS services section, you can go ahead and type in Snow in order to access the Snow family services. Once you log into your account and access the Snow family services, you'll see the list of all the Snow jobs that you've created to date. You can click on any one to see more detail and actually see the status of that job. So whether it's been created, provisioned, and shipped, and then when you're ready to return the device, you can also track all of those return activities. Now, in order to access your Snowball, you'll need to get some credentials, including a unlock code and a manifest file, and we'll dive into that in just a few minutes. But this is where you would access that information. Now, if you're ready to create a new Snowball job, click Create Job, and you can see these 7 steps that are part of the process to create a Snowball job. First, you select the destination country. This will default to the country that your account is located in. And then you have 3 choices: an import into S3, an export from S3, and local compute and storage only. The import into S3 option gives you the ability to take information that you collect out into the field and have it automatically synced back into your AWS account once you return your Snowball device. So if you're collecting large volumes of imagery, it's a great option to choose import into S3. Now, export from S3 is if you have a need to bring a large volume of data with you, but you don't want to package it up into an Amazon machine image. So if you're interested in exporting a large volume of data, you would choose export. And then local compute and storage, you don't want to take anything in or take anything out of AWS. You're just interested in local compute and storage. For this example, we checked import. Next, you want to provide your shipping information. Either create an existing address, choose an existing address, add a new one, and then select the shipping speed after provisioning. Next, you'll want to give this particular Snow job a name so you can easily find it in your console. And then choose which of the Snow family devices you're interested in. As I mentioned earlier, there are a couple different options. An AWS Snow Cone is actually a shoebox-sized device that has up to 8 terabytes of storage and 4 gig of processing power. The Snowball Edge compute optimized device is the one that we selected here. It has 42 terabytes of storage available and up to 200 gig of processing power. There's also a Snowball Edge compute optimized device with GPU, which gives you the option to acquire Snowball that has an NVIDIA Tesla V100 GPU card for those high intensity compute workloads that you might want to run on a Snowball. And last, the Snowball Edge storage optimized device. This is a 100 terabyte of storage device, and it's ideal if you're looking to, say, do large scale data transfer, maybe from an on-prem data center to somewhere else. We're going to go ahead and, for this instance, select the Snowball Edge compute optimized device. Next, you want to choose an S3 bucket that's linked to the Snowball device. And this is what's used for either the import or the export job. So if it's an export job, the information in that bucket will be copied to the Snowball before provisioning. If it's import, when you return the Snowball, any information in that bucket will be copied into your account. Now, if you'd like to use compute on the Snowball, you want to click this box to enable compute with EC2. And then you want to go ahead and select an Amazon machine image out of your AWS account to provision onto the Snowball itself. Now, the Amazon Machine Image gives you the ability to really pre-provision and pre-configure all of the software that you might want to take with you into the field onto that Snowball device. And so as you're creating that EC2 instance in your account, you're able to snapshot it into what's called an Amazon Machine Image or an AMI. And when you're provisioning your Snowball, you would click Add an AMI, and you would see the list of Amazon Machine Images that are available to your account, and you can go ahead and select one or more of those in order to provision to your device. Now, as a best practice, especially for disaster response, we recommend you provision, think about flexibility in the field, think about what you might want to be able to do, think about whether you may or may not have additional connectivity readily available, and select maybe a couple Amazon Machine Images. You can actually also sideload AMIs now if you have connectivity later in the field. So there's some additional functionality and flexibility there. Last, you can check to compute and pre-provision some Lambda function onto your Snowball. We're actually going to skip that step. We don't need that for this particular example. So when you're ready, click Next. And next, you'll go ahead and set up security and permission and encryption for the Snowball device. So in order for your account and the Snowball to be able to interact with one another, you need to set up what's called an identity and access management role so that the Snowball has permission to be provisioned from your account. And then when the Snowball is returned, if you're doing an import or an export job, that the Snowball again and the account both have permission to interact with one another. So in this demo, we'll go ahead and we'll go ahead and select an existing IAM role to add into this account. But you could always create a new one if that's what you wanted to. Next, you can do some configuration related to the encryption that's on the device. You can use the default, or if you have some custom encryption, you can choose that. Now, the next step is to set notifications. If you recall, you could see all the steps in the process of provisioning and delivery, and all of the steps are on the return side. So you can use what's called an Amazon Simple Notification Service topic to list off a set of email addresses that you'd like to be notified as the Snowball progresses through those setup and delivery steps. And again, you can create a new one or choose an existing one. Next, you want to download AWS Ops Hubs. AWS Ops Hub is a graphical user interface that makes it super simple, super easy for you to access and interact with the Snowball once you receive it in the field. So this is just a quick view into the Ops Hub interface. You can download either a Windows or a Mac version. Highly recommend it. But you can also use command line. And once you are finished, you review all of the parameters and come back into the Snowball account. Come back into your AWS account to see the list of jobs. And that is how you provision a Snowball device. So next up, we'll take a quick dive into how you actually use the Snowball device once you receive it and it's been provisioned and shipped to you. So once you receive your Snowball device, the first thing you want to do is plug it in, turn it on. It does take a few minutes for it to start up, so you'll want to be sure to give yourself a few minutes. It can be a little bit noisy, so 2 or 3 minutes, and then it quiets down to just a low hum. You'll want to most likely either set up a networking cable or connect in a router that's transmitting a Wi-Fi signal that you can connect to from your laptop. And then open up Ops Hub. When you open Ops Hub, you'll see these 3 choices. You can interact with a snow cone, a snowball, or a snowball cluster. And now you have the choice. You can either access with existing credentials, like the unlock code and the manifest file, which you access from your Snowball account. From your AWS account in the Snow family. If you recall, you can go ahead and open the job, click on the Get Credentials option, and from there you'll be able to copy down the unlock code and download the manifest file. And you need both of these to be able to unlock and access your Snowball device. So we'll go ahead and copy out the unlock code here and download the manifest file locally. Now I can come back in to Ops Hub, click Next, and this is just a friendly reminder. If you haven't yet, go ahead and turn on your Snowball, make sure the front panel and the back panel is open, and spend a few minutes connecting in a router, taking a look at the information that's displayed on the front side of the panel around the status of the startup of the Snowball device. And when you're ready to go, just click Next. Again, this is where you want to enter the IP address that's assigned to the Snowball device. You can find that from the front panel display on the Snowball. So you want to copy that down and enter it into this view and click Next. Now you'll want to go ahead and paste in that unlock code and select the manifest file from where you have it saved and click Next. And now the Snowball device will unlock. And this takes a few minutes longer than what you see here. We've sped it up for purposes of this demo. Next, you want to give your Snowball a name. It'll just make it easier for you to go ahead and access it in the future. So once you're into Ops Hub, you actually can see all of the resources that are available to you on the Snowball. So you can manage storage, you can get started with compute, you can launch different activities. You can see how much memory you've used, how much storage you've used, how much is available, and also what the status of the instances on your device are. When you're ready to get started, click that Get Started button, and this is where you can see we have the 2 instances that we provisioned onto the Snowball are available. Now they're both in a stopped state, but it's easy to go ahead and start them. Just click on the checkbox next to it, and then go ahead and click Start. And you'll see the display is updating to tell you that those instances are getting started and they'll be ready to use in a short amount of time. Now, if you want to create or launch your own instance, you can do that as well. You would click to launch, then choose from the Amazon machine images that you had downloaded, and now you can choose from any number of different Snowball instance types in order to load that AMI into that instance type and have it available to you. So if you want to load the AMI with your image processing software up and have a number of instances running in parallel, that's how you do that. Now it'll take a few minutes for that newly launched instance to show up in the panel. So let's hop into this one and take a look at some of the additional details that are available to you. And you can see the instance ID, the number of virtual CPUs. You could choose to terminate this instance from here or edit it. And now when we come back to the main Ops Hub display, you can see that the new instance that you launched is in a pending state. And now, with the other 2 instances running, you have the ability to access those instances, access the software that's running those instances, set up those jobs, kick off your imagery processing pipeline, and just use the Snowball as you need it to perform whatever activities you decided you wanted to perform in the field. So with that, just a brief reflection on the outcome of the field test. So using this field test, we were able to demonstrate that the Snowball Edge was able to process imagery in that disconnected environment using a generator and turn around that information much more quickly in order to be useful to those local decision makers. With that, I'd like to wrap up with a little bit more information about how you can learn more about the AWS Disaster Response Program, and really appreciate and thank you for your time today.